Okay, this is going to be the second video on section 2.6, and this is going to be looking at the chordic surfaces. We're going to start off this video with the elliptic cone. An elliptic cone is going to look like x squared over a squared plus y squared over b squared minus z squared over c squared, and that's going to be equal to 0. It does look a lot like a hyperboloid of one sheet, but the difference here is this is equal to 0, whereas the hyperboloid, so this being the elliptic cone, is equal to 0, whereas the hyperboloid of one sheet is equal to 1. The variable that is negative, that's going to be the variable that the cone opens up along. Here we have in example 4, we're going to sketch x squared plus y squared minus z squared is equal to 0, and so this is going to open up along the z-axis. So let's go ahead and put in our coordinate system. When x is equal to 0, we have, label my coordinate system. When x is equal to 0, we have y squared minus z squared is equal to 0. So for our yz trace, if we solve this, we have y is equal to plus and minus z, so that's going to be the positive and the negative identity functions, y equals z. And so we'll go ahead and graph those. So first we'll put in the yz just for some perspective. Okay. All right. So when z is 1, y would be 1, z is 2, y would be 2, and likewise z being 1, the y would be negative 1 and negative 2 because of that plus minus. And then on the other side here, okay, so again, if z is 1, then y would be positive and negative 1 because of the plus and minus. All right. Now, if the y is equal to 0, then we have x squared minus z squared is equal to 0 on the xz trace, and this is going to be very similar to what we just did for the yz trace. And so we're going to have x is equal to plus and minus z. So to give us perspective, we'll go ahead and draw in a little bit of the xz plane here. So it'll certainly go through the origin where all three of the planes meet, the coordinate planes or the coordinate axis. Okay. When z is 1, x would be positive 1 and negative 1. So you also have negative 1 over here. So I've plotted 1, 0, 1 and 2, 0, 2. Okay. All right. So kind of have like an x there. So again, if z is 1, then x would be both negative 1 and positive 1. Okay. All right, and then z is equal to 0. We have x squared plus y squared is equal to 0. And for the xy trace. Now that is only true at the 0, 0, 0. So let's switch it up and make z equal to the square root of 2. Then x squared plus y squared is equal to 2. And so then we'd have a circle here, and we'll go ahead and connect here and try to draw our cone. So there is our cone. Now I'll draw in some more circles here to try to communicate the idea that it's a cone. So maybe this will help make it a little bit better. And maybe you guys are a little bit better artists than I am, and hopefully you can kind of see the cone there. And let's move on and let's draw another one. So let's look at the elliptic paraboloid. And the elliptic paraboloid is going to look like z equals x squared over a squared plus y squared over b squared. And so what would be an indication here that it's an elliptic paraboloid? Everybody's positive, and we have one person to the first power, one variable to the first power of the z. The variable that is to the first power, that is going to be the axis that you open up on. So we'll go ahead and sketch this and label our axis. If the x is equal to 0, so specifically we're going to be looking at sketching x equals z squared over 4 plus y squared. So it's an elliptic paraboloid that's going to be opened up along the x-axis. Okay. So if x is equal to 0, then we have z squared over, sorry, it's not 4 squared. And this is going to be equal to 0. Okay. And for a yz trace, and the only value of x, y, and z that's going to satisfy that is 0, 0, 0. However, if we let x equal 1, then we have 1 is equal to z over 2 quantity squared plus y squared, and this is going to be an ellipse. So it's going to be 1 plus minus 1, 0, and 1, 0 plus minus 2. That's going to satisfy the equation there, so we're going to draw an ellipse in right here. So there's an ellipse. We could also let x equal 4. So 4 is equal to z over 2 squared plus y squared, and that's also going to be an ellipse. Okay, so we're going to have 4 plus minus 2, 0, and 4, 0, plus minus 4 are the vertices there, so we'll go ahead and plot those. And so now we have a larger ellipse. All right, and moving right along, let's go ahead and let the y equal 0. And we have x is equal to z squared over 4, and so this is going to be a parabola. So we're going to have the points 1, 0 plus minus 2. Also 0, 0, 0 is on there. Okay, so we'll plot those, and then we got our first paraboloid there. And then maybe we'll do one more. 4, 0, and plus and minus 4. Alrighty. And so that is, let's try to sketch this a little bit more. A little bit of a bowl there. Alright. We're going to look at one more trace, z equals 0, so we're going to look at the xy trace. So then we're going to have x is equal to y squared, so that's just going to be a parabola. Okay, so our vertices are going to be 0, 0, well, 0, 0, 0 is going to be the vertex, excuse me. And then we'll have the points 1 plus minus 1, 0. And then 4 plus minus 2, and 0. Okay. And this would be our elliptic paraboloid. We can draw in some more ellipses there to kind of try to get the effect there. Okay. Alrighty. I got one more for you. We're going to be looking at the hyperbolic paraboloid. It's going to look similar to the elliptic paraboloid, but the only difference is you're going to have one negative. So you're going to have one variable to the first power, the other two variables squared, and one of them negative. And so this is the hyperbolic paraboloid. It's also called the saddle. Okay, so I'll set up our coordinate system. And so we got y is equal to x squared minus z squared. So we'll just go through and play the same game. X is equal to 0, then we have y is equal to negative z squared. So this is going to be a parabola. Okay, so we'll have the origin as a point on that parabola. And then we'll have 0, negative 1, plus minus 1 on the parabola. So we'll plot those points. We'll also have the point 0, negative 4, and plus minus 2 on the parabola. So we'll plot those as well. Okay. So that's one of our parabolas there. And so what's going to happen is we're going to have our person. I'll try to draw a crude shoe here. Our person here, and their leg is going to go right there. And so they probably should be wearing boots anyways. So they're wearing boots. And that's where their leg is going to go on the saddle. But we'll go ahead and keep going. All right, let's do another one. Let's do x is equal to plus or minus 1. And so then we have y is equal to 1 minus c squared. And this is also going to be a parabola. So points on this would be plus minus 1, 1, 0. Plus minus 1, 0. Plus minus 1. So plot those. Plus minus 1, negative 3, and plus minus 2. Okay, so we got some more of our saddle going on here. All right, and so this is going to be your lowest point here, and then the saddle starting to go up here. Maybe you got your reins here. And then the back end of the horse would be over here, for example. All right. And we can do one more, or two more actually. X is equal to plus or minus 2. So then we have y is equal to 4 minus z squared. That's also going to be a parabola. So we have plus minus 2, 4, 0 as a points. Plus minus 2, 3, and plus minus 1. Okay, so another part of your saddle. And then we'll do one more. Plus minus 2, 0, and plus minus 2. Okay. So the more I put on there, the harder it's going to be to see the saddle. But let's keep going. Okay. Y is equal to 0. And we're going to have x squared minus z squared is equal to 0. Solving that, that's going to give us x is equal to plus minus z. So we can plot a little bit of that. Okay. And then we would probably do. No, let's just leave it at that. This is going to make it messier. Okay. And let's look at z is equal to 0. We have y squared. Oh, sorry, y is equal to x squared. So just your regular parabola. So it's going to have the point 0, 0, 0, plus minus 1, 1, 0, and plus minus 2, 4, and 0. Okay, and so this parabola I have in purple is kind of like the main parabola that all these other parabolas are going to come off of. So you got the orange, and then you got the red, and then you got the blue. So all those parabolas are coming off of the purple parabola there to form our saddle. Okay. Now, if we clean this up a little bit, maybe we can try to make it look a little bit more like a saddle, because we are drawing stuff that we wouldn't see from our perspective. Maybe put another part of the saddle in. All right, and so then again, here would be the shoe. Maybe it should be a boot, and then we'd have the person there sitting on the saddle. Okay. All right. Well, I think that is. Let me see what I had written here. I was overwriting something here. Okay, so we're just making more of a mess. Okay. So that'll be it for this video here. Stay tuned. I think this is the last video for Chapter 2, so stay tuned for Chapter 3. And we'll see you next time.